Hey there, AppSec engineers. Welcome to another video in the Application Security series. I'm Ganga, and I'll be walking you through mass assignment vulnerabilities in Node.js applications. In January of 2023, GitHub faced a significant security incident when a researcher discovered a mass assignment vulnerability. It was in their user profile update API. The vulnerability allowed attackers to modify account permissions and potentially gain administrative access to repositories that they should not have access to. While GitHub security team quickly patched the vulnerability, it highlighted how even tech giants can be susceptible to mass assignment attacks. So what is mass assignment and how does it occur? Mass assignment is a vulnerability that occurs when an application automatically binds user inputs to internal object properties, and this happens without proper validation. Think of it like giving someone a master key to your house when they only have asked to access the front door. In the GitHub case, the API endpoint responsible for updating user profiles was not properly filtering which fields could be modified through the request. According to OWASP data, mass assignment accounts for over 12% of API security incidents. The average cost of remediation for mass assignment problems is over $100,000 per incident. This is seen to be particularly dangerous in financial applications where privilege escalation can lead to unauthorized transactions. Before we get into the attack section of this lab, let's examine the vulnerable Node.js application that manages, in our case, expense approvals. Let me switch to our hands-on labs. Before diving into the attack section, let us take a look at the vulnerable code and understand what is happening. Our expense controller in the Node.js application contains a method called updateExpense. This updateExpense method uses the entire request body to update all the parameters within the expense object. Notice how the application directly passes request body to find by ID and update. This means that any property in the request body can modify the corresponding field in the database, including sensitive fields like isApproved that should only be modified by managers. Let's go ahead and exploit this vulnerability. First, we'll authenticate as a regular employee, in this case, Maya Williams. In a real attack scenario, this could be any legitimate user account. Notice that Maya is a regular user and not a manager. She shouldn't have expense approval privileges. Let's go ahead and copy her authorization token for further use in the application. To begin with, let's examine Maya's current expenses to understand the normal state of the system. You will see that she has two expenses listed, one a dinner at an airport cafe, and the second a car rental fee, both of which are not approved. Because we understand that the application blindly accepts all fields from the request body without validation, we can go ahead and modify the expense object including the isApproved status. Let's craft a request that exploits this vulnerability in particular. In this case, we will be updating the expense while sneaking in the isApproved field. You will see in the response that we have successfully approved the request, which an employee should not have access to and only a manager should. If I were to go back and get the list of all of my expenses, I will see that the Gunrock Cafe expense is now true or is now approved. Let's analyze why this attack is significant. From a privilege escalation perspective, a regular user has performed an action that was reserved only for managers, and therefore they have bypassed the application's authorization controls. From a security control perspective, we know that authentication is working correctly. We are using the token that was generated for only our user. However, the authorization bypass was through mass assignment. Further, this was perpetuated because there was no input validation and there was no field level access control. Going further, we could also change other fields within the same object. For example, the amount field could then be changed from, for example, $30 to $3,000. Further, it is possible to exploit these vulnerabilities in batches. Automated scripts could modify multiple expenses, and there is a potential for large-scale financial fraud. Now that we understand how this attack works, let's look at how we can prevent it through proper validation and field-level access control. There are two methods that this can be done. The first is a blacklist approach, wherein fields within the object can be blacklisted. Because we know that the isApproved field should not be tampered with by non-managerial roles, we could blacklist it by saying that this field must be excluded every time a request is made. However, we quickly understand that this is not a scalable approach. Instead, we can take the whitelisting approach. This time, you will see that instead of taking all of the request body, we define an array of allowed fields. In this case, the merchant, the amount, the name, the project, and the reason for which this expense is being made. And only those fields are allowed to be updated by this user. Some key takeaways in this case. You never trust user input directly for object updates. Implementing explicit whitelisting of allowed fields is always better than using blacklists that are more limiting and therefore not scalable. In fact, using separate endpoints for privileged operations is always recommended. Finally, regular security audits can help you identify and catch mass assignment vulnerabilities before they can turn into problems. Hope you learned something, and catch you in the next one.